Hello, hope everyone is doing well. As you know, students, in the previous lessons we have studied the polynomials, operation on polynomials, and factorization methods and strategies. Our today's lesson is rational expressions. Okay, what's rational expressions? As it's known from its name, rational is derived from ratio. Ratio, it means a number which is divided by another number. And expressions or algebraic expressions that we have studied at the previous lessons. Okay. A rational expression is an expression written as the quotient of two polynomials. In other words, a rational expression is an expression of the form p of x over q of x, where q of x doesn't equal to 0. It means we have two polynomials, one at numerator and the other one in the denominator, where the denominator doesn't never equals to 0. Okay, for example, the expression x squared minus 7 over x squared plus 3x plus 1 is an example of what? Rational expressions. Why? Because we have a binomial at the numerator and a trinomial at denominator. That both of them is an example of polynomials. When they are written in at this form, it means p of x over q of x. This means it's a rational expression. And also 2x to the power of 5 plus 5 over 5x minus 1 is also an example of rational expression. Okay, we can perform the same operation on rational expressions that we perform on rational numbers. It means we have operations multiplication, division, addition, and subtraction on rational numbers. It means the fractions 1 over 2 plus 1 over 2. That's a rational number. And also we have those operation on rational expressions. Okay, in order to study the operation on rational expressions, first of all we have to study how to simplify or reduce rational expressions. Okay, the first strategy in order to find a common factor or simplify a rational expression is factorization that we have studied in the previous lessons. Okay, first of all, in order to simplify our rational expressions, we have to factorize the numerator and denominator completely. It means if it has a common factor, we have to find it out and we have to take it out of the parentheses. Okay, at the second step, we have to divide both the numerator and denominator by each common factor. Okay? Okay, note, first of all, if two expressions are the same, then their quotient is 1. Second one, if two expressions are additive inverse of each other, then their quotient is minus 1. Okay, for better understanding, let's pay attention to the examples. Okay, first example, 8a squared b over 8a squared b is equal to 1. 5a minus 3b over 3b minus 5a is equal to minus 1. And I'm going to teach you why they are 1 and minus 1. And also, this rational expression a minus b times c minus d over b minus a times d minus c is equal to 1. Okay, dear students, as we studied at the previous page, if two expressions are the same, then their quotient is 1. Okay, let me check the first questions. 8a squared b over 8a squared b. The variables are the same, their powers are the same, and the real numbers are the same. So we can simplify easily. 8 goes by 8, 8 squared cancels by 8 squared, and b is cancelled by b. So the answer is simple and a, just 1. Okay, at the second note, we have said that if two expressions are additive inverse of each other, then their quotient is minus 1. What's the meaning of additive inverse? Okay, look, we have 5a minus 3b. And at the denominator, we have 3b minus 5a. It means, look, real numbers are the same. Variables are the same. Same here, 3, same, b, same. Just here minus and here plus. Here plus, here minus. It means they are additive inverse. So by factoring just a minus from the numerator, or it doesn't matter, from the denominator, we can simply can cancel them. Okay, if we just take a minus out of the parentheses, so if we take a minus here, so the answer is minus 5a what? Plus 3b. Why? If we again multiply this minus with each terms, then we get 5a minus 3b. It means doesn't matter. Our 3b minus 5a. So, minus. We can switch their positions. Doesn't matter. For example, 2 plus 3 is equal to 3 plus 2. Doesn't matter. Okay? And here also we can switch their positions. 3b plus 3b plus 3b minus 5a. Okay, at the denominator also we have 3b minus 5a. Okay, then look, they are the same. 3b minus 5a, 3b minus 5a. We can cancel them easily. The answer is minus 1. Did you understand? Okay, the third questions. A minus b times c minus d, and also b minus a times d minus c. As these questions, look, we have a minus b here, and at the denominator we have b minus a. We can take a minus out of the parentheses, then the answer will be minus a plus b. Also, we have c minus d, and at the denominator we have d minus c. We can take also one minus out of the parentheses, minus c plus d over b minus a and d minus c. Okay, I told you at the previous question, when we took out this minus, it doesn't bring any changes to our questions. Okay, and also if we multiply again this minus with each terms, then we get this. Okay, doesn't matter. Okay, is equal to minus. Also we can switch their positions, b minus a, and also another minus here, d minus c. At the denominator we have b minus a over times d minus c. You know that these minus represent minus 1. Am I right? These minus represents minus 1. Okay, then we can cancel them. B minus a with b minus a, and also d minus c with d minus c. We have minus 1 here and minus 1 here. Minus 1 times minus 1 is equal to plus 1. Okay, did you understand? This simple, easy. Okay. Exercises. First, simplify 5x minus 10 over 2x minus 4. Did you understand? 5x minus 10 over 2x minus 4. So, in order to solve this kind of question, we had a strategy. Okay, first of all, we have to find the common factors. After finding the common factors, what should we do? We should simplify if possible. Okay? And here, from the numerator, 5x minus 10. Okay? What should we take as a common factor? Okay, we have 5, we have x minus 10. Okay, at the numerator, first term, we have a real number and also a variable. At the second term, we just have one real number. So we cannot take the variable as a common factor. Okay, and 5 and 10, we can logically, if we think, we can take 5 as a factor, because between 5 and 10, the GCF or greatest common factor is 5. Okay, we are going to factor the 5. Okay, then what should we do? We should divide this term by the greatest common factor, or GCF. 5x over 5, the answer will be x minus 10 divided by 5 is equal to 2. Okay, if you again want to go to this expression, you can one by one multiply this common factor with each term of the expression. 5 times x is equal to 5x minus 5 times 2 is equal to 10. Okay, from the denominator, also same like the numerator, we can just simply take 2 as a factor. 2x divided by 2 is equal to x. minus 4 divided by what? Divided by 2 is equal to 2. Okay. Look, we have two expressions which they are same. It means we can cancel them easily. X minus 2, look, in here 5 over 2 times x minus 2 over x minus 2. Okay, we can simply cancel them. So the answer is 5 over 2. Did you understand? Did you get it? Okay, look at the second question. Simplify x cubed minus x squared plus 4x over 4x squared minus 4x plus 16. Okay, let me check. What is the GCF or greatest common factor of, look, GCF? In order to factorize, we have said that we can what? We can find the factorization or the common factor from the greatest common factor. Okay, greatest common factor of x cubed minus x squared plus 4x. So, what is the greatest common factor? You have to take the variable with the lowest, what? With the lowest power. So, x cubed, x squared, and 4x. So, what's the greatest common factor of each of them is x. Why? Because it has the lowest power. Okay, x. X cubed divided by x is equal to x squared minus x squared divided by x is equal to x plus 4x divided by x is equal to what? 4. In the denominator, this was the solution of, okay, at the denominator, 4x squared minus 4x plus 16. Look, we have 3 real numbers and just 2 what? Variables in the different terms. So we cannot take x as a factor. Why? Because at the last term we don't have any variables. So what is the common factor? What should be? Yes, 4, because 4 is in each term. If you take 4 out of the parentheses, the answer will be x squared. 4x squared divided by 4 is equal to x squared minus 4x divided by 4 is equal to x plus 16 divided by 4 is equal to 4. Look, we have x squared minus x plus 4 right here and also in the denominator. So we can cancel them, okay? We can cancel them easily. So the answer will be x over 4. This is the answer. For better understanding, let's practice a lot. Okay, the third question, 16x plus 32 and also x plus 2. So from the numerator, what should we take as a common factor? Yes, 16. Why? Because 16 is in this term and also in 32 as well. It means 2 times 16 is equal to 32. So we can take it as a common factor. So 16x divided by 16 is equal to x plus 32 divided by 16 is equal to 2. And now at the denominator, we don't have any specific real number or variable to take as a common factor. So we write it itself. And here we can cancel them. Why? Because x plus 2 with x plus 2 are the same. The answer is 16. Okay, students, thanks for paying attention to the video. If you have any comment, if you have any suggestion, just comment. Thanks for watching.